Good morning, afternoon, evening. Welcome to the CADclass podcast. I'm Josh.
I'm Jake, and Josh stole that from the Truman Show. How dare
Did I?
you? Yeah, good morning, evening, afternoon.
I didn't even. Those of you who know me know that I don't watch movies. I can't watch movies.
I
It's
don't get it.
impossible. Movies are impossible, Jake.
Josh has slept through every single movie I've ever recommended to him. Every single.
Of the yeah, of the 12. Yeah, I don't know what it is. My brain just doesn't. It just doesn't work for my brain. This is one of the things I think that's not really talked about. Hey, in school, right? So we're teaching. We're teachers here. One of the things not really talked about in school is what you get to learn about yourself as you get older. Like,
Mm,
you live in this bag of skin your entire life, and you'd think you knew everything about it. And yet, the older I get, the more I'm like, "Oh, other people see when they read, they can actually picture what's happening in
mm,
they can imagine characters in their brain, they can hold them in there, and then they become these
yeah.
dynamic beings." I can't do that.
What?
I can't do that. Cannot
That's
picture
bizarre.
cannot picture a character in my head.
I only just
But
learned recently that not everyone has an internal dialogue.
right?
Is that not the weird? There's people walking around, like a healthy amount of the population with no sounds going on upstairs. I'm like, that's bizarre. That's
Meanwhile,
weird.
I'm out here, my internal dialogue is speaking itself into the world. I'm
Yeah,
walking around like, blah, 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 blah,
never
and
ending.
occasionally I bump into somebody, I get all embarrassed about it, like, "Oh, no." Saying something weird, and I'm like, "What did I just say?" Oh, so yeah, I spew mine out. Anyways, good morning,
What a
printed
good
by
intro.
John PC Van Vliet, Cadence, Cornelia, Connie. It is really
Hello,
lovely
hello,
to be
hello.
here with you all. Jake and I are jamming. I can't believe this, Jake, but we're about to produce a book in a little bit over a month. We talked about this a couple times on the pod previously, but from start to finish, we are writing the Fusion Fundamentals workbook to accompany the BFB for a couple of reasons. One, the BFB, as we're calling it, the Big Freaking Book. The Big Freaking Book it's project
Intimidating.
based and it's intimidating and it's difficult to pick it up and know exactly how to teach from it. So
Mhm.
Jake and I have been teaching Fusion Fundamentals training for educators, and we basically teamed up with our co-author Ed on who wrote the Mastering Tinkercad book, and we said, why don't we just turn this 12-hour course that we're teaching for educators into a book? And this
Mhm.
time we did not ask ourselves how hard could it be. This time we knew exactly how hard it was going to be. And
We
yet,
more asked ourselves, how quick can we possibly
how
do
quick
this
can
and
we get this
still
out?
uphold our high standard?
Exactly.
And it really does just equals, well, how red are you willing your eyes to get before you go to sleep?
That's right.
And mine is pretty damn red.
Yeah. So we're
Every
gonna
night I
keep
go to bed, I'm like, oh my, look like a teenager again.
Jake's eyesight is getting worse. I
I
feel
know.
somewhat. Let me ask you a question,
I
Jake.
feel
I feel
aged.
I feel somewhat like we're a band, and we are
Mm,
trying to produce music, and we're just in that phase where we've got a pretty good rhythm with the two of us, and also with Ed, where we're just smashing stuff out as fast as we can,
mhm.
and then trying our best to make it as good as we can possibly make it. And we're in the early stages of, well, how much stuff can we produce as our band? We got hit a couple of times, right?
I think that's a good allegory. It's even more poignant when we're like on trips and we're still working. So if you've never seen the Rush documentary, I can't remember the name about the band. It is absolutely hysterical. And they were just saying like, yeah, anytime we're on a tour bus going to different venues, we would be writing songs. He's like, that's what everyone used to do. There was never this point where you stopped performing and then started writing. It would just be constant. So they're just telling stories. They were like, oh yeah, there would be parties next to us for us, and we would all be in a little hotel room writing and like reading old mythology books and trying to write romantic lyrics for nerds. And I'm like, it's kick ass.
Yeah.
That's kind of what it feels like a little bit sometimes, a little bit.
Jake,
But
wait, can I spend like 2 minutes talking about the actual structure of the book, because I think it's relevant to how
yeah,
people should go about learning Fusion. And it's one of
mhm,
the things where when we plop projects in front of their face and say, do this, do this, do this, do this, I think that works tremendously well.
mhm.
And I'm a huge fan of it because I like to make stuff. And I hate it when people talk to me about the possibility of making stuff and all the things that we could do without actually doing it. I'm on a I'm on a tirade against that sort of teaching. However, we have a couple of new styles of pages that I think are going to really resonate with some of the newer learners. One is the overall structure. We start with a tool. So we picked projects that introduced a specific tool like Loft or not Shell,
Sweeping,
sweeping, Loft,
all the really
extruding,
the fundamentals, as you
revolving.
imagine.
And then we force people through a reinforce and stretch section to go, what did you just do? Can you edit some values? What does it look like if you do this again? Can you combine that with something you've done earlier to make something more interesting? And so this, we're going to teach you how to do something, how to use a specific tool, a lot about that specific tool. And then at the end of it, we're going to come back and we're going to help you rethink about what it is that you just did. I'm actually pretty excited about. How do you feel about that?
Yeah. Well, it's so the idea of having this really thick, gigantic book and then coming out with something that is much simpler, much smaller, much faster, just gives you the basics, just gives you the fundamentals in as easy and efficient way as possible. Hopefully, the book is just supposed to be full of light bulb moments. Like what we hear from everyone that's learning, that's gone through our first chapter is, oh my God, I've been doing it wrong. And all the things that I thought was the right way to do it was just the fix. And we hear this all the time. Oh my gosh, that's the tool I've been looking for all these years. Oh, that's how you do it. Oh, that's what this means. And it's just, after chapter 1, it's just light bulb moment after light bulb moment. And so we wanted to compress that as much as possible so people are really understanding bare bones of it and getting to grips with it, but also comfortable. And normally when you can apply that to literally every single software on the planet, every single tool that's been going on for hundreds of years. But every single one of those concepts we've always thought was fantastically boring. And so we've technically already written this book a long time ago, and now we're rewriting it because we're like, that sucks. It is ungodly boring to go, this page is about extruding. Look at all the things you can do with it. This page is about lofting. Here's all the stuff you can do. And it's like, dude, can I just make something, please? So we're trying to find a middle ground where we still make really fun projects because that's what we want. That's what we like to do. And kind of join that with trying to teach you guys as much of the fundamentals as possible, as quickly as possible. So there's going to be some stuff in this book that isn't in the BFB, and there's going to be some stuff in the BFB that isn't in this. But hopefully, together, cohesiveness.
Well said. Yeah, well said. I think it's worth mentioning here. We mentioned it last week on the pod as well. Is if I'm imagining that a handful of people in our community are either already are or going to be teaching this at some point, because I think you get good at it. You recognize how powerful and interesting and important it can be. How many things you can make. You get excited by it, and then because you're the one who knows it, and not very many people know CAD very well. People by default start asking, hey, can you teach me? Or do you have classes on this kind of stuff? So point being, there's going to be a student and a teacher instructor guide. That's the student workbook is going to be super inexpensive. It's going to be accessible. It's going to be something that you could actually use to teach a 12-ish hour course over, say, 2 to 6 sessions, depending on how you structure it. So it's meant to aid our community's ability to continue spreading the word. So we hope, and of course, as usual, we'll have the link to the PDF for free or for a donation, and then an accessible book at that lower level. So that's another reason I'm really excited about it. And I think it has a lot to do with empowering our community. We've seen what you can make. We've seen what you can do. We've seen all of the exciting stuff. I get excited seeing this every single day. And now it's like, what if we could empower you all to do that for the rest of the world? And so that's my pitch. If you can even call it a pitch, but we're stoked to see what happens. And hopefully it's not a complete disaster. I don't think it will be. I think it'll be good. And we're going to use it to teach anyway. So anyways, enough chitter. We only have about half hour today. So
we're in a bit of a rush.
Take it away. I stole it.
I want to talk about something really quick first. I did something this week that I haven't done in a long time. I made something and it failed. So I love clockwork and geared mechanisms and all things like that. And there's a thing in that universe called a tourbillon, which is I believe it's a clockwork mechanism. It's essentially those super duper fancy wristwatches that have like that ball that kind of clicks and rotates in two different axes. That's a tourbillon. I think the idea is that it essentially smooths. It's like a mechanical capacitor. It smooths and slows down the resistance of all the clicks, and so the output is much smoother, I believe, but I don't know for certain. And there's been 3D printed versions of these for years, and I've always loved them. They're just so kind of beautiful and mechanical systems like that. I love, and I'm like, do you know what? I'm gonna have that going in the background while I'm working. Let's do it. And the file that I found is this little handheld thing. You can find it on Printables. It's about the size of like a baseball, and the top comment is 1 star. The tolerance of this is insane, and it's so difficult to build. And I'm like, whatever, I can make it. It took me 3 goes to get halfway through it, and it failed. It completely failed, and I feel terrible. And it's such a complicated design that as I was doing this, I was like, well, if it was twice the size, maybe the tolerances would be a little bit easy to work with, would be a little bit nicer. And it was one of those moments where I'm like, this is such a complicated design, such a complicated amount of mechanisms that go into it. I'm like, damn, I don't know if I could like whack this out in CAD easily at all to actually make it for myself. If I make it for myself, I know all the tolerances, I can use all the hardware that I have, I know everything's going to be perfect. But I'm like, dude, that's a crazy amount of design that goes into this, that humanity has put into it. And I'm like, I don't know if I can make it in my amount of time, if I can do it snappily enough.
Well, there's some philosophy in this. This is something we talk about occasionally, and that is you don't always have to make everything. So
On this one,
just
I
be-
do, because I feel like
I'm saying you do. I'm saying though, you found a design, you printed it. Now you found out that it failed, and so maybe you need to work backwards and make the thing. But if you just wanted to have one and not necessarily wanted to design it, which is it sounds like what you wanted. Like even people who spend their entire careers in CAD don't always make stuff. Yeah, and then Dan was saying it makes sure your clock runs the same speed in all orientations.
which makes sense.
That
But
does
it's a
make sense.
really, really lovely thing, and I've been meaning to make a mechanical clock 3D printed for 10 years now, and I haven't. And I feel like I need to do it. It feels
I
like
have a
one of
thought,
those things
Jake.
I need to
I have a
do.
thought.
Go
We
on.
have the I made a thing. I really love the I made a thing. Right?
Yeah.
Look at all the cool stuff I did.
Mhm.
Do we need the opposite? I failed a thing.
I
I failed a thing. And that's where we discuss our failures. Oh
I
shoot, I
think
tried this.
that's not a bad idea.
I failed a thing. Because look, in life, we learn more from failures.
Mhm.
When you fail at something, you experience this pain, and it forces you to go through the process of trying to understand what might have happened. So you don't learn like, oh, look, we had hit after hit. I'm so successful in all the things. Like that's just not how the human brain is wired. You fail, you experience the pain of that failure, and you go, hang on a minute, like what do I need to do to solve this problem here? So I think
it could be a bit cathartic.
I
So
think I need
Discord
an
is
I failed a thing.
so Discord is technically a social media platform, technically. And the kind of common trope among people who have anxiety looking at other people's creations and like, oh, I wish I could do it, is, well, people, and this is not just making, this is all social media. People don't post their failures. So you look at, oh, I graduated from high school, this dude, and he's doing amazing. And I get all this anxiety with it. Well, it's like, yeah, but they're not posting this horrible thing that, oh, I'm really terrible at this. Oh, I lost that. This happened to me. Got fired. They don't post that because why would you? And I think it could be a little cathartic to not just post all the amazing stuff you've done, but to say, I made this and it was catastrophe. Look at my big bowl of spaghetti on my printer. I think it's kind of nice.
I think I'm gonna have a fun time doing that. I failed a thing because I think even for the newbies, right? The people that are new to this coming into it, they're seeing these people make these complicated, intricate, amazing models, and they're going, I can't do that. I'm so far away from the possibility. They don't see the struggle that it took you 6 weeks to figure out why your sketch wasn't constrained and it was breaking in step 2, right? And it was something, they don't see that. So, okay. All right,
Especially
we're
with
gonna
like
run.
YouTubers, all the projects that you see, all the people that you love that are makers, that they go, oh my god, they're so intelligent. I will never be able to make stuff that well. I'm completely forgetting the name of the guy, but he's an amazing maker and he does a lot of CNC stuff. He's the guy that made a robot chainsaw to carve out all these projects. Totally amazing. And I'm like, I will never be able to get to that level. And then I remember that we've talked to a lot of YouTubers, and they're like, yeah, we don't film the 5 failures that we tried to get to this final project. If what is on screen still kind of doesn't work, it is the best of what we have done. So I'm like, yeah, that sounds about right, man. That sounds about right.
All right,
So
so
I
we're
think we should
gonna
definitely post a
let's
failures.
run an experiment. It's gonna be I
Okay.
failed a thing or something
All right.
like this. I don't know if I failed a thing will fit in the Discord length.
I
We
think it
might
will.
have to
Yeah.
we might have to modify that a little bit. But I failed a thing. That's where you discuss and show and take pictures of the things that didn't work, and then we talk about why and what happened and what you learned as a result. Here we got printed by John, and I can see the chat's kind of popping off. We got a couple people talking about it. So I made a little hanger for my mom's hot pads, and then next week my sister broke it. So I'm making another. Yes, 3D prints. Man, the number of 3D prints that I've made, I'm like, this perfectly solves my problem. And then 2 weeks later, it breaks because it wasn't designed well, because the structural support wasn't there, or whatever.
Or because it's
It's
made
got to
out
be
of
at least a
PLA.
half a dozen to a dozen.
Yeah. The amount of things that I make that I'm like, oh yeah, this will be really handy for my car, and then I leave it out in the sun of Southern California,
Yeah.
and then I come back and it's a little melty. It's a
I
little
made
melty.
I made a light switch cover because every time I open my refrigerator door, it turns the light
Yeah.
on.
That was
And
one of our
the
first shorts as well.
it was, and the extrusion part that blocks it from hitting the
Uh-huh.
refrigerator
Yeah.
is big enough. So it like barely works. You hit it, if you push it hard enough, the light like flickers and dims a little bit. I'm like, okay. So
Yeah.
this like partial success is still a failure in my book.
Yeah.
But
Yeah. That's all right. Um,
uh
as we said, for anyone that's new coming in right now, we are in the process of writing another book. Fingers crossed, we're going to be clicking the publish button on Friday. That's just going to be for our first prototype, for our proof, so it's not going to be available on Friday or Saturday. But we will let you know later down the line, which why this is going to be a slightly shorter podcast than normal. But what we're trying to do at the end of all of our podcasts is basically finding a pretty common CAD project example, something that you'd find in a CAD engineering test for school, or sometimes in an interview for a job. Ooh, and trying to recreate it. But I'm literally one of the first times, or the first time I've ever seen it is this morning, and I've literally looked at it for maybe 5 seconds. So yeah, I will be making it. It's on the Discord on the challenges page if you want to make along. Uh, but the whole goal is to try and make it in fewer steps than me. So I've seen it. It's a little. Let me look at it again really quick. Yeah, it's a tubey thing with 2 flat sections and a bracket, and then 2 ribs in between. I tried to make it in a ridiculously short time span just to get my heart rate up. What time do we want to put on it, Josh? I because last time it took me, well, I didn't even finish it, and you gave me 10 minutes or something.
yeah, so maybe I don't know how much time I give you, but maybe we check out last week's. So a bunch of people made it from last
Yeah, I
week,
did it.
and we see because I think Connie posted her time. It was like 13 minutes it took her.
Oh my god,
Something ridiculous like this. And then what I really loved is that people were going back and forth about reducing steps, and a couple of
Mhm,
folks, I think Derry and Connie
mhm.
ended with the same final solution. It just
Yeah,
converged on a 10-step, and they were like high-fiving each other in the Discord. So
yeah,
freaking cool is
that's
that,
rad.
man.
That makes
I'm
me really
just
proud.
loving it.
All
Uh,
right.
you want to show them off?
Let's show them off. Yes.
Yeah, and then we'll have you
Just
quickly jam. I say I'll give you 7 minutes.
give me 7 minutes.
Mhm. But, you can have everything up and ready, and you can have a look at
Seven
the
and a
picture.
half. Give me 7.5 minutes at
Okay.
least.
Okay, 7.5 minutes it is.
Oh,
Yeah,
I don't know where my Discord is. Do 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 do. Here we go. Um, yeah. So this is going to be the newest one. It is fairly simple, but it's got some tricky bits as far as referencing one distance from another. This was made in SolidWorks, which is why obviously all the tools are different. But the actual drawing should be pretty much the same. But this should be fun. This should be cool. But from last week, we got a bunch of people. Dan made it in Timecodes as always, mind blowing. But Connie, yeah, making it in 10 steps. That's ridiculous. So silly how good you guys are at this. Blows me away every single time.
Yeah, Dan's ability to continue to make these things in Tinkercad, I'm still like, what and what kind of madness is this? It's really
Kind
impressive.
of maniac.
Yeah, it's amazing.
Yeah, it's absolutely fantastic. All right, I'm God, you guys make these
Look at these, and
so easy.
it's funny, right? Look at even the appearances. Derry's posting his. I'm like,
I know.
oh yes, I just love this like brat.
No.
This
No. This is Derry rubbing it in. This is twisting the knife, going, and I rendered it.
Yeah.
Yeah, whatever, Derry.
This just makes me think of Mario and the pipes in Mario. Like I feel like I need a Mario character to slide down that tube and come out the edge, and like suddenly you're in a secret level.
Oh my gosh, 7.5 minutes. Oh my god. Okay. All right.
All right.
Oh, by the way, this is the Tourblin. If you have made it or you think you can make it, good luck. This thing was a pain in the ass. Okay. This is gonna be our Discord. I'm just gonna study it just for a little bit. Okay, so it's going. I'm a mad. So if you can see these L bracket kind of on the left hand side, and on the front side is 2 different levels. They're 15 mil, or they're actually coplanar but on different planes. So that could be kind of handy for extruding the right hand down and the left side up. This has got holes on a different plane. Ooh, that's a hard one. Oh, this is mighty. This is mighty difficult. Okay. Okay. I have a. Oh God. Actually, no, I don't. What the hell? Okay. Okay. So I was gonna say I have a plan, but I actually don't have a plan because this is actually more strange than I thought. So as always, we want to try and see all the individual features of a part that we can remove because it's just a single step. These 3 holes that I'm seeing, these small ones, this ring extrusion that feels like it's going to be one piece, these 2 ribs on either side, this kind of rectangular one, this triangular one, those can be symmetrically extruded at the same time. The actual profile, so it looks like this width on the back is the same as the diameter of the tube. So that can come out at the same time, but it can't be a part of the same sketch, or it can't be a part of the same extrusion as this lower one, because this isn't as much. This has got a radius of 46. So although I could sketch it, I can't actually do much with it. It's also got a radius. Ooh, funky. Okay, all right. All right, I've studied it a little bit. All right. You ready to go?
Oh, we've already started.
This is not. You started seriously?
7.5 minutes. No, I didn't start yet. 7.5 minutes. Right. And okay. I'll just constantly do the.
Okay. Yeah. Give me the minute. Okay.
Yeah.
Terrible. All right, you ready to rock?
I'm indeed.
Okay. All right. Count down. 3, 2, 1.
3, 2, 1, go.
Okay. All right. So I'm going to start off on the top plane. I'm going to start off with the tube. Actually do both of them at the exact same time. So notice the outer one has got a 60 millimeters diameter right there. And then that inner wall has got a 40 millimeter diameter. Lovely. Then I'm going to do essentially a top-down grooving. So that vertical tube, I'm going to do that at the exact same time. That's going to be coming off the edge, totally horizontally, clicking and dragging, good little trick, and then continuing onwards. I'm going to make sure these are both tangent, and I want to make sure that the arc and the circle are collinear. That one is not perfect. There we go. And then we also want to add a horizontal constraint between the center of the circle and that arc, but that's already done. Is that all symmetric? Yes, it is. Lovely. All right, so that's got a 20 and then 23. So 20 millimeter diameter and then 23 mil radius. Is that right? Cool. So that's 30. What is that? 75 from the center. Okay. 75 from there. As always, we want to get as many things on our sketch as possible, but I can't really do that with the upper sections. This left-hand side, I actually want this to be on the front plane. So I'm going to go ahead and extrude that up 15 mil. Like that, 50 millimeters upwards. Go back in our sketch, turn that back on, and then I want to extrude that ring up 60. There we go. Okay. All right. So far, I have three features right now. Like I said, I want to do the ribs at the same time. Let's go ahead and go on the front plane. I want to make it on the front plane. We're going to make this little L-shaped thing, and it's going to be collinear, that top section. I need to project that face. Let's go ahead and make a line that connects those, and then going off of there. That wants to be horizontal because the underside of the left-hand side is totally coplanar to the top section of that right rib. Let's get a touch off there. What is the size? That's going to be coplanar at the very top. Lovely. Ooh, How width is that? 45 and 15. Okay. Does anyone like the search tool? No?
No,
Good.
I do.
Because it's awful. Oh, yeah, that's right. It's already defined. Here. Oh, that's so ridiculous. Okay. What is the distance? 60 to that wall. Okay. 60 to the origin. Fantastic. Is that going to define that? No. What is the thickness there? 15. Okay. 15 mil there. Fantastic. Okay. So then I want to extrude this profile symmetrically. But it needs to wrap around, doesn't it? Yeah, it needs to wrap around. So, oh, bugger. I should have done that second then. Bollocks. Okay. So that actually needs to extend in to the body a little bit because it needs to wrap all the way around. So I want to actually pass that all the way to the origin and have that be coincident. But then I need to cut it through. That's an extra step. Damn.
That's all right.
Okay,
You're going for speed on this one.
Going for speed, you need to make this 30 for the half width. That's going to be a joint connection, but then I need to add on another feature because this little bit, this annoying thing, that needs to be cut downwards. Okay, and then I can make a new sketch on that front plane for those ribs. I believe this is just going to be a flat section, and then it's going to be a triangle. Is that all the way to the top on there? Yes, it is. It's 25 from the front. Okay. So it's 25 to there. That's going to define that, but because it's curving... Oh, bollocks. Okay, I actually need to move some stuff around.
I like how you get more and more British as speed is increased.
Is it?
Oh,
well,
bollocks.
I get more British as I drink as well. So I think that's got a little bit of cultural significance to it. Okay, like I said, I need to make both of these. Oh, that's not a profile. Come on, Jake. Come on. So I need to join up those two sections because it's still not a profile. There we go. Okay. Oh, for God's sake. That needs to be more inward as well because that's got a wall thickness. What time am I at?
You got 2 minutes left.
I actually think I've got it. I think I do. I just want to define that because I'm a good person. Nope, it's 10. That's right. Okay. And then I'm going to extrude those three profiles. Again, I need it to be symmetric. What's the distance? 10 millimeters. It's got half length of 5. Lovely. Join. As you can see, it's cutting into it a little bit, which sucks. I'm going to be pulling that. This cut that we did for that flat section. Oh no. I can't click on that little corner, so I'll have to do it from the underside. Oh, that's so ugly. Okay. So then I have to click on that little sliver of a face and then bring that upwards. Oh, that looks awful. Okay. So that, and then the last two things are the circles, essentially. Be on the back side. I'm just going to mirror one of them. So that can just be a mirror plane. That's a circle. What the hell is the size? 16. Groovy. And then 35. What's 35 divided by 2? Is that 17 and a half? 35 divided by 2. It's 15 mil down from the top. Lovely. I want to mirror in the sketch, not in the 3D, because that would add on another feature to my timeline. Good little trick there. It's like those two. Distance to all, but then I need
T minus 30 seconds.
Oh my god. I'm actually going to set it to distance. Click on that wall. Click OK. Did I do it? I think there we go. I think I got it.
With 15 seconds to
Yay!
spare. 15 seconds to spare. Jake, let's
15
double click on a
seconds?
couple things that you said here really quickly. So one thing you didn't do is you were like, "What's 35 divided by 2?" And Fusion will do that for you.
I ended up typing
Fusion
it in
will
the
do that
dialog
for you.
box
You
anyway.
can type in 35 divided by 2 as a dimension, and it will go ahead and calculate that for you. That's one thing I noticed. So I'm going to get tips and tricks quickly based on what you just did. And then you said you were going to mirror the sketch entity instead of the body. Are there other examples where mirroring the body versus the sketch matters?
Yeah.
And why does it matter? Because I think this topic is worth very quickly
So
talking about. And then,
for time efficiency, if it's just for yourself, patterning or multiplying or duplicating anything in a sketch is always more efficient than doing it as a feature and then a three-dimensional pattern or a three-dimensional mirror, because that obviously adds an extra feature. So something that would normally take three steps, you only need to do it in two. But also at the same time, having the fewest amount of features is just a skill to make you a better CAD modeler. It's not actually what you want to do in real life. If I was going to be giving this file to another person or actually working on it in the future when I've forgotten what I've done, then making it in many more features than it really needs to be is always going to be better. Always going to be better.
love it. I would for some reason I've been wanting to do the print and play stuff for a little while. So if I'm going to challenge our audience to find us some of these drawings that are print in place.
That's a good one.
If you could find us some print in place drawings, I would love to start to model up those print in place mechanisms. And also, by the way, I think like that, since that's a whole new manufacturing discipline, basically, because it's uniquely available, you're uniquely able to do it in 3D printing. It's sort of an emerging engineering idea. And I want to see how far it's been pushed so far. So for two reasons, right? See if you can find the challenge to the audience outside of this challenge is see if you can find us a drawing related to a print and place mechanism or something else that we can maybe use as a modeling challenge. And number two, 7.5 minutes. Or Jake, can you post your timeline?
I did. I just said 10 steps.
10 steps. So there you go. 7.5 minutes if you're going for speed, or 10 steps. I actually think you were 7 minutes and 15 seconds. Now you can study the drawing beforehand.
I think that's a good rule.
Look at it beforehand, spend a little bit of time thinking about how you'd like to make it, and then pop in and go from there. And as we mentioned at the beginning of the pod, I think that is the pod. We've got a book to finish, Jake.
That's going to be it. I have to go and write 150 pages of a book today. All right. Why do we do this to ourselves?
I don't know about write.
Well, design. I need to design 150 pages.
Alrighty. This has been the CADclass podcast. Once again, I'm Josh.
I'm Jake.
And we'll see you next week.
Later, guys.